I have an exponential equation here and I would like to solve it. One of the tools that's available to me is to take logarithms of both sides, but before I can do that, I need to have the exponential term isolated. I need to have it by itself. So I'm going to fix that, and the way I'm going to fix that is to add 5 to both sides. And so that's going to give me e to the x minus 1 is equal to 10. Now, since I have the exponential term by itself, I can take logarithms of both sides. Now, what base am I going to use? Well, the base of this exponent is e, and so I'm going to take logarithms in base e of both sides. Now, base e is one of the special ones, and so instead of writing log with the base e, I'm just going to, the shortcut, the abbreviated form is to take ln. So I've done the same thing to both sides, so I still have equality. Now we're going to use a logarithm rule called the power rule, is one. And the power rule, I mean, that's one way to describe it. The power rule says if you've got a logarithm of something m to the rth power, the exponent r, can just come out the front. So I'm going to do that here. I'm going to apply the power rule, and so this exponent is going to come out the front. And everyone should know this if you're taking a course. The natural logarithm of e is just the number 1. So this is x minus 1 times 1. And so we have that. Now it's time to solve it. So to solve it in the original equation, you're just supposed to find out what x is. And I'm in a very easy position to do that now. I'm just going to add 1 to both sides. Okay, so this is my exact answer. Now, if we have an approximation, say to 4 decimal places, whatever. So you might have different instructions, but I'm just going to put ln of 10 plus 1 into my calculator. So I'm going to click the ln button of 10 and then click plus 1. So to 4 decimal places, you have x is approximately equal to 1, 2, 3, 4, and then that 8 is going to bump that 5 up to a 6. Okay, so sometimes a question will specify whether or not they want you to give an exact answer or to give an approximation. Okay, let's go on to the next one. Okay, same thing. I want to solve this exponential equation. A tool that I have is I can take logarithms of both sides, but in order to do that, you have to have the exponential term isolated, and this is your exponential term right here. That needs to be by itself, and so the way I'm going to do that is I'm going to divide both sides by 7. So after the cancellation here, I have that. Now I'm going to take logarithms of both sides. What base do I use? Well, the base here in this exponential term is 10. So I'm going to take logarithms of both sides with respect to base 10. That's the common logarithm, and so it's just written log. We don't even bother writing the 10. Now, once again, I'm going to use the power rule. If you have a logarithm of something raised to a power, then the power rule says that that power can come out the front. And once again, it's a common result that the logarithm of base 10 of the number 10 is just equal to 1. So ln of e is equal to 1 and log of 10 is equal to 1. And so this becomes 6x times 1, which is just going to be 6x. Now, if I want to find x, because you've been told to solve it, which means find x, then I'm just going to divide both sides by 6. Or you could say multiply both sides by 1/6. This is the same answer. So if you look it up in the back of a textbook, you might see it like that, I would think. Either one of those works. That is our exact answer for x. And now again, if I'm told to approximate to 4 decimals, then I am going to put in my calculator, I think this first way is probably, I'm going to use the LOG button of 33/7, close parentheses, and then divide that by 6. And then if I take that to 4 places, this 3 here will not change anything. And that would be my answer. Okay, so again, it depends on if you're asked for exact or approximate. If you're doing these problems in My Math Lab or web work, you're going to need to take your answer to at least 3 decimal places before it will accept it. Okay. All right, and let's come to our last problem. Okay, now if I'm going to take logarithms of both sides of this, I do have that the exponential terms are isolated with respect to them being on each side. So I don't need to add or subtract anything to both sides. I don't need to divide anything but both sides. But what I notice here is I have 2 different bases. This is base 2 and that's base 7. So, especially if I've been asked to give an approximation, I would like something where I use the LOG key or the LN key. So it really doesn't make any difference. I could take natural logarithms of both sides, or I could take the common logarithm of both sides. So I'm just going to choose ln, but you could go back and rework the steps and use log, and you will get the same result. Okay. So that's what I'm going to do. I'm going to take natural logarithms of both sides. So I will still have equality since I'm doing the same thing to both sides. And once again, I'm going to use the power rule. So that's that third property of logarithms. And the power rule says if you have a logarithm of something to a power, the power comes out the front. Make sure you put it in parentheses because it's all of x minus 5 times ln of 2. If you leave the parentheses out, then you're going to have x minus 5 times ln of 2, which is not correct. Same thing here. If I apply the power rule to this, then the power comes out the front. Put it in parentheses, you must do here. Now I'm going to just distribute. So I'm going to multiply on this side the ln of 2 through. So I'm going to have x times ln of 2 then minus 5 times ln of 2. And I'm going to use the distributive property on this side. I'm going to multiply ln of 7 by each of those. So I'm going to have 4x times ln of 7. And then minus 1 times ln of 7, which is just that. Now the goal is to solve this. So the goal is to find x. And so we want to get any term that has an x with it on the left-hand side. LHS is left-hand side. And anything without, so all other terms, we want to get on the right-hand side. So anything with an x with it, we want on the left-hand side. So now I'm going to erase that. So this will stay because it's on the left-hand side. That does not have an x in it, so I'm going to take it to the other side. And the way I take it to the other side is I'm going to add 5 times ln of 2 to both sides. Now this has an x in it. It needs to be over on the left-hand side, so I'm going to subtract that from both sides. Okay. This does not have an x in it, so it needs to stay there. So these will cancel, and these will cancel. And so what I'm going to be left with over here is x times ln of 2 minus 4x ln of 7 is equal to, I'm going to start with the positive term first, 5 times ln of 2 minus ln of 7. Now over on this side, the reason why I wanted to get everything that had an x in it on the left-hand side is I'm going to factor out the x. If I factor out the x, so this side stays the same, what are we left with? Well, if I factor out an x from this, I'm left with ln of 2. And if I factor out an x from that, I'm left with minus 4 times ln of 7. Now, to solve it, I need x by itself. So I'm going to divide both sides by whatever x is multiplied by here. So these will cancel, and I'm left with my exact answer for x, which is this, but I'll write it all in one color now. Now, if you saw this answer in the back of the book, they'd probably use the logarithm properties and combine those, but you don't need to for this because I can imagine that you would more than likely be asked for an approximation. So if you put that in your calculator, what would it be, say, to 4 decimal places? Well, here's what we're going to do. Now the numerator is going to be 5 times ln of 2 minus ln of 7. And then I'm going to press enter. That's my numerator. Then I'm going to press divided by, but now that entire denominator has to be enclosed in parentheses. So parentheses ln of 2 minus 4 times ln of 7, close parentheses for ln, close parentheses for the denominator. Now I press enter. And so my answer is going to be to 4 decimal places. So that 4 will not change anything. Okay, so there's my exact answer, and there is my approximation. So those are the 3 examples for this video, so I'm actually going to stop it here. And thanks for watching.